feet high building. Using antiderivatives, calculate the impact velocity of the object with the ground.
Okay, so here's our drawing. First, we have that our height is going to be 100 feet and our initial velocity is going to be 0 because it is dropped from a building to the ground. If you remember from Math 5, in application to physics, we first had to obtain the position, then the velocity, and then the acceleration. But since we are in Math 6, we have to do it
the other side.
First, we're going to obtain the acceleration, then the velocity, and then the position. So first, we have that our acceleration is a constant. Since we have feet, it is going to be minus 32 feet over second square. So we apply an antiderivative to obtain the velocity. It's our step 2. And the antiderivative is minus 2 our f dt. Then velocity is minus 32t plus c1. Always our velocity is going to be c1 and our position is going to be c2. Since our c1 is velocity, our constant is going to be 0. So our general formula is this one, and the particular formula we substitute c1 for our value in velocity. At the end, it's going to be minus 32t plus 0.
So this is the third step, and from the general formula, we need now to do another antiderivative. So we separate, as we know, the coefficients of all the stuff, and we got the rule. This is the result, and if we divide it out, we have this, that this is the general formula of now the position, and we have this, that is the particular formula, because as Monse says, the C2 is the 100 feet, so we substitute here, and we have this, that is the particular formula of the position. Now, in order to find the time, we need to clear out the t from the position equation, that is the general, it's a particular formula. And we clear out t, and we have that t equals 2.5 seconds. And now, with this value, we are going to substitute it in the velocity formula, and we have the velocity that the problem asks. And the final answer is minus 80 feet over second. So the theory that we need to know, as Monse says, is that the general formula is the formula that has the c, and this is not a number, it's the c. And the particular formula is the antiderivative, but with the coefficient that the problem gives us, like here that is 0, and here that is 100. And as Monse says, this is applied to physics, because this 100 is the height and this 0 is the velocity, and this is how we can find, like in our problem, the impact of velocity at the end.
In order to solve the antiderivative, we have to simplify our first function and then antiderivate the function and evaluate it with the first value we got. After we have our first value of c2, we need to antiderivate it again and evaluate with the second value. After we have that, we need to substitute the first c1 and c2 formula and solve it in order to have c2. To get the answer, we need, with our first general antiderivative, we need to substitute with the values of c1 and c2, and then we have the final answer.
Thank you very much for your attention.